So let's move right along to our last speaker, but definitely not least. Charles, or I've actually never heard anyone call you Charles, so Chuck McCulloch is professor and head of the Division of Biostatistics at UCSF and the vice chair of the Department of Epidemiology and Biostatistics. So he has expertise in the development and use of statistical methods for longitudinal data analysis, mixed models, and latent class models. Many of you have probably used the textbooks he has authored and co-authored, because there are many of them. And so instead of going through all of them, I'm going to just turn it over to you, Chuck, and thank you for being here today.
Thank you. Let me get my screen set up here.
Looks beautiful.
And I don't know about you, but this is what I sort of feel about the pandemic. I usually give the dates I give these presentations, but this just seems to be sometime in 2020. But to emphasize things that both Steve and Tor have said, it's really important to document things and when they happen in time, because as we move forward, and I'll emphasize this, we're going to have to be able to do sensitivity analyses, and it's good to record those things in real time. So I sort of feel like I'm the mop-up person because there's not really that much to add on top of Steve and Tor's excellent presentation. So I'll try and drill down a little bit and emphasize a few things. And as both of them, happy to respond to questions. So I got started thinking about this because of an example in group prenatal care. I'll talk about that. Then I'll talk about how to incorporate pandemic effects and my point of view of looking at this, which Starlee in her comment is sort of foreshadowed, thinking of it as an interrupted time series design, and talk a little bit about the sort of ways of doing that. So I'm involved in a study with Miriam Kupperman, an Embrace study. We'd recruited 100 participants in only of a planned couple thousand of a prenatal care intervention. It's like, oops, and we hit the pandemic. Primary outcome was premature birth, secondary outcomes, depression and anxiety. I use that sort of as a toy example throughout my talk. So we're pausing to retool the group prenatal care group, trying to think through what the analysis will eventually be. Judy Hahn chatted, have anybody asked for funding for these things? This is a PCORI contract. Miriam did ask for funding to help retool the intervention to be remote. Got funding for that. I've been involved in another study, which is school-based intervention. Yeah, good luck with that one. And we asked NIH for funding. It's been approved. We haven't actually seen the money yet, but the point is those things are possible. All right, so, just to reemphasize some of the stuff that Steve and Tor have talked about, what could be the impact of pandemic interruptions? Could increase the rates of premature birth, could increase depression and anxiety, might happen equally in both arms, or it might happen unequally. Maybe knowing that you're enrolled in an intervention could have a mitigating effect. Change in the intervention from in-person to remote could reduce its effectiveness compared to, pre. And you often may have to change data collection methods. Things I've been involved in the school-based intervention. We have to do food frequency questionnaires. Those were done in person on a tablet. Now they're going to be remote over Zoom. So that sort of could introduce a change. Populations may change. The target population is changing in Tor's example. Willingness of people to participate may change. These may lead to changes in the analysis and what you're measuring. All right, so let me try and condense that all down and get away from the idea of causes of things and think about what's the bottom line with regard to trying to get this research out the door and get it past reviewers. There's a multitude of things that are going to change the average values that you're measuring, the average values that you're modeling as part of this analysis strategy. And so thinking through it from that lens may help it be a little less overwhelming in terms of thinking about all the things that could have caused the changes. So that's sort of my viewpoint. All right, so my lens in thinking about these is the lens of an interrupted time series. And there's plenty of ongoing studies. I've helped people try to design a lot of these, trying to check the impact of the pandemic. And they're usually using an interrupted time series design. For example, is the pandemic increasing premature birth rates, or is the pandemic reducing prenatal care visits? So those would be interrupted time series sorts of analyses. And graphically, it sort of looks like this. So here, just as a toy example, I'm thinking of this as the depression scale. And this is the time axis. And these are the measurements that are pre-pandemic. And these are the measurements that are post-pandemic. And in my little toy example, I've drawn one where all of a sudden the hit of the pandemic, and I'll come back and talk about this in a minute, causes depression to increase. Right? So in its very simplest form, what does a interrupted time series analysis do? It creates a model like this, pre and post, and measures the effect by looking at how much of a jump happens at that one time point, in this case, when the pandemic hits. All right, so again, in its simplest form, what is interrupted time series model? It includes a secular trend. That's just a time effect. In its very simplest form, maybe it's linear. It includes a sharp change at the time of the interruption, and you test significance of that sharp change. Now, there's a lot of variations on that model. I'll talk about a couple of them, but that's its very simplest form. All right, so my basic sort of takeaway message is that this sort of way of thinking about things and the same sort of strategy and modeling may be an avenue to removing pandemic effects. And Steve and Tor have already sort of talked about these in terms things like pandemic main effects. And so what would be the general strategy? Include a secular trend, include a sharp change, a potential sharp change. You can always check and see if it's there. But instead of the focus being on the interruption and the effect of the pandemic, that's now a nuisance part of the model. And that has to be accommodated and removed, but it's not going to be the main focus. And so I want to talk a little bit about that sort of strategy that's already been outlined by Steve and Tor. All right, so here's the simplest form. So again, I'm thinking about depression as the outcome. Here's my time scale. This was in response to a question that Mallory had. Yes, here we're hoping that we're going to have a nice return to normality. Maybe true, maybe not, when things like vaccines kick in. And so you can have different panels where there's just a pandemic effect during this period. Okay, now I've drawn sort of the very simplest model where there's a disruption and then there's a return. But the effect, the study is comparing an intervention and control group. Of course, we can compare more, where the effect is constant. That is, the gap between the red, which is the control, and the intervention, which is the blue, stays the same, whether that's pre, post, or during pandemic. Okay, so that's a very simplistic assumption. That's one that can be accommodated fairly easily. When might you be willing to believe that's a reasonable thing? Well, maybe if what the main change is the measuring modality, and you expect that measurement method might have equal changes in the control and the intervention groups, pre or post-pandemic. That maybe is a simple situation where you might believe there are only pandemic main effects. It raises or lowers the entire measurement and doesn't change the relative size of the intervention effect. So that's the sort of thing that could be fairly easily accommodated. Here's a slightly different modality. Here I've drawn it where you can see during the X's, during the pandemic period, the intervention is less effective. So now there's a simple form of interaction, which is that we need to include a pandemic by difference between the treatment by pandemic interaction. So again, that's not the fullest form of interaction that you might have, and it's a simpler form. Again, this one is, if you've got sufficient data, I'll talk about this in a minute, may be possible to first check for and then deal with as part of the analysis. All right, so what's the basic idea? The basic idea is to check to see if the size of the intervention effect is stable during as compared to not during the pandemic. And you do that by allowing effect modification in your model, or statistically an interaction term between the pandemic effect and the interaction. This is the way we would assess that the possible existence of that previous effect I showed on the graph. if you've got sufficient data, you can test for effect modification. Now, it's important to realize that testing for interaction often has low power. So I don't advocate sticking with a strict rule of p less than 0.05. I like a combination of being a little more liberal here, checking, maybe p of 0.1, 0.15, and also being guided by the size of the effect, because I've seen lots of situations where an interaction effect isn't statistically significant, but it's hugely important in terms of the size of the overall effect that might be estimated. And so I would certainly modify my approach to this if I saw large interaction effects, even if they weren't statistically significant. So again, I advocate being sort of liberal there. And as Tor mentioned, I would start with the highest order interaction terms and check to see if you can remove them one by one, hoping to do so. And if there doesn't appear to be effect modification for the key parameters of interest, that could be just the difference between the two in a observational study. It could, in a cross-sectional study, it might just be the association. In a longitudinal RCT, it might be the group by time interaction. If that is not affected by pandemic interactions, then you can consider pooling. And if you're building these sort of complicated models, as soon as you drop out those interaction terms, what you're getting is a pooled or combined estimate combined across the pandemic and non-pandemic periods. All right, so what about some variations, some caveats? There may be higher order interactions. So here I've drawn a situation where at the beginning of the pandemic, the intervention isn't as effective. Maybe there's difficulty transitioning it to work in the pandemic. Maybe people are getting used to delivering it. Who knows? There's lots of possible explanations. And then towards the end of the pandemic period, or at least towards the end of what I've drawn here, it's approaching the pre-pandemic intervention effect. So again, these can be modeled. You may or may not be able to detect these effects. And again, I return to Tor's main point is need to be prepared to do sensitivity analyses to explore these sort of things. I'm not sure I can, in good conscience, recommend doing all of them ahead of time. You're going to run into the cranky reviewer who's going to ask you to do sensitivity analyses, sometimes interminable ones. What it is important to do is to collect the information and to record in real time the information you're going to need to do the sensitivity analyses if you're called upon to do them. Of course, you're going to do the obvious ones, but you might need to be prepared to drill down in a little more detail. Here's another variation that, again, I think has already been raised, but again, I think it's worth reemphasizing. So here I've drawn a situation where the pandemic starts here, but you don't really see the effect here. You see a delayed effect. And that could be a couple of reasons. One is maybe the pandemic has a delayed effect. Second of all, we know that the pandemic effects weren't instantaneous. I mean, when did shelter in place happen? When did people start getting worried? When did people actually change their behavior in exchange and in response to the pandemic? So again, you're going to need to be prepared to vary what you consider to be the time the pandemic actually had an effect on your analysis, which may not correspond to the instantaneous time that the first cases appeared in the Bay Area or wherever your study is, or when shelter-in-place rules went in. Steve already mentioned, this is not always going to work. The very extreme situation where all your pre-intervention or pre-pandemic, all your post-intervention or pandemic, the pandemic effects are hopelessly confounded with the intervention effects in this case. You're not going to be able to separate them out. And so you do have to be doing the things like Steve and Tor recommended, which are sort of mapping out where your data is in relation to pandemic. All right, so when you're fitting these complicated models, how might you know that you have a problem? So I'm going to advocate that you try to fit these interaction terms with pandemic group by time, those sorts of interactions. And what's going to be the evidence that you don't really have the data to support this more complicated modeling effort? Well, if it's really extreme, if it's completely confounded, SAS or Stata is going to tell you. SAS is going to say it's non-estimable. We can't actually estimate this higher order interaction term. You don't have sufficient data to do it. Stata will also call it non-estimable for things like margins commands, but it tends to return empty when you ask for parameter estimates, and the data just won't support it. It may not be that extreme. As Tor and Steve emphasized, you may have just a little bit of data that allows you to estimate these effects. So I also advocate keeping track of standard error. So look at the standard error for your group by time interaction. Look and see how it changes when you put that three-way interaction in for pandemic. If it quadruples, let's be extreme. Let's say the standard error goes up by a factor of 10. How do you interpret that? Well, the effective sample size scales according to the square of the standard error. So if your standard errors go up by a factor of, let's say, 10, when you put in a triple order interaction, what that effectively means is that you're only using 10 squared 1/100th of the data now in the new analysis. Even if it goes up by a factor of 3, you're basically only using about 10% effective sample size to answer the questions you were answering before. So, certainly you're going to be alarmed if you see standard errors going up by factors of 3 or 10. If they don't go up by much, if they go up by 50%, you're still using effectively most of your sample size to get your estimates. That's a relatively safe region. And SIFNess, if things get really complicated, consult your friendly neighborhood statistician. Steve mentioned this what's sort of equivalent to like a pattern mixture approach to missing data. And if you are in the comfortable situation where you have a small number of rigidly scheduled visits, this may be a nice alternative approach. Often you won't have this. Sometimes you'll have haphazardly scheduled data. The pandemic may have messed up the timing of all these sort of visits, which case you can't really comfortably put them in this realm. Also, if you have a lot of follow-up visits, this runs out of steam because there's just too many different patterns. But if you have a small number of rigidly scheduled visits, then an alternative to just using the pandemic indicator is to use what Steve outlined, which is to categorize these as patterns. So for example, baseline pre-pandemic, 6-month is pandemic, 12-month is pandemic. That's one pattern. And you can look for interactions with these pattern indicators also as a way to diagnose whether it's comfortable to pool data or not to pool it. So let me summarize. The basic idea is to think through these as like an interrupted time series design. You have an interrupted time series for your intervention and your control group or all your intervention groups. And this may be a way to remove pandemic effects from ongoing studies. As emphasized by the previous speakers, this is going to work best when you have sufficient data both pre and post-pandemic, so you can accurately assess the interactions and decide whether or not you need to include them, whether you need to segregate the analysis by pre versus post, or whether you feel comfortable pooling the data. If you were able to remove these interaction effects, that's equivalent to getting pooled estimates. And again, I would argue that you should all put on your cranky reviewer hats and think through to when you go to publish a manuscript using these data that span pre and post pandemic, what do you think reviewers are going to ask you to do, and be prepared to do them, both on the, what are the pandemic effects, and also on the missing data side, because almost certainly these are things that reviewers are going to be asking for. Thanks.
Great. Thanks so much. I want to open this up to questions for Dr. McCulloch, but also for all of the panelists. It's been really helpful to listen to all of you sort of lay out the issues that we're dealing with, and I'm sure that other folks have a lot of questions. They might not have a friendly neighborhood statistician to be consulting, which, by the way, I love that phrase. I've never heard that before. So I'm not sure if folks want to just jump right in. Okay, no takers. Judy, I see Judy raising her hand.
I'm kind of curious about thinking about, like, you sort of use this binary pre-post pandemic, but you also alluded to the fact that sort of the pandemic effects may kind of have been changing over time. And thoughts on maybe exploratory analyses to before you kind of jump into just dichotomizing in March or something. I'd love to hear that.
So, I'll take that one, but others can feel free to chime in. So yeah, that was that one picture I drew where the intervention effect was sort of escalating after the pandemic. If you have sufficient data, you can do it graphically. You can, draw these with smooth plots, for the model, but you may have to do it in a model-based way. For example, there's a lot of sensitivity analyses that people do with interrupted time series models, which include allowing a post-intervention slope change in addition to a sharp change at the time of the intervention that models the effect. If there's no gap, but there's just a slope change, that models the effect that there's a slow change over time. And so those are typical sort of variations that I would always recommend that you do as sensitivity analyses in interrupted time series modeling, whether you're using it to accommodate both intervention and control or just doing an interrupted time series design.
Okay, there's a poll that just popped up on your screen. Hopefully you can move it so you can still see.
For Judy, one issue is that as you kind of consider a finer grained breakdown of pandemic statuses, so you've got pre-pandemic, initial pandemic, big spike, return to semi-normal, another spike number 3, you could break it down a lot of different ways. And the more fine grained you are, the less likely you will have each of those states observed at all assessment times, which will limit how robust your model can be to accommodating all those pandemic states in a robust way, where you could still get your group by time interaction effect. So there's going to be a trade-off potentially a trade-off in terms of how fine-grained you are and how robust your model will be to excusing pandemic effects as a nuisance factor. So I think it may in a lot of cases fall into the sensitivity analysis domain to consider those variations. I'll also say, in response to your earlier question about funding or extra time from NIH. So if perhaps you decided to augment your study design and that extended your study calendar, perhaps beyond what you initially planned for your study period. And I think so far in my experience, NIH isn't promising anyone any extra money. But I think if you ask your program official, if you have a plan that's going to extend your study timeline because of the pandemic, whether or not they might consider a second no-cost extension, I think that's a reasonable question.
Yeah, I was thinking more, if you say, shoot, I have to throw away those first, 50 people I enrolled, can I get money to replace if anyone's treated with that line of reasoning?
Yeah, if it's an observational study, as people were talking about, the idea of rebaselining those people. If it's an RCT where those folks have already experienced some of the intervention, then you can't really rebaseline them. So there's different circumstances there as well. But actually, I have had a double no-cost extension before. Most people might think it's not possible, but I think that in a pandemic era, I think that NIH might be pretty willing to consider a second no-cost extension. So think about that when you're mapping out what the possibilities are for your study.
Anyone else want to jump in with a question? I know folks are feeling shy today. Well, I'm not sure if you guys want to talk about anything else that you decided not to include in the presentation because it was so jam-packed already, but I'm sort of curious what you guys called away. And Tor, I see you smiling, so I know there's something there.
I don't know if Tor wants to speak, but you know, one of the big issues that Tor did touch upon, but is a little bit thorny, is if you have an intervention study and you've got some participants who had a fully pre-pandemic intervention dose, and some who had a fully pandemic era intervention dose, and some who had a mix, what are you going to do about that? Let's say you chose to have a pre-pandemic or a post-pandemic estimate, you know, you might just want to be very pure about intervention content. But even if you have a pooled data estimate, you know, and maybe Tor talked about this, the sensitivity analysis he did. So that's something that I think deserves a lot of thought, probably more thought than was represented in our comments today, depending upon how kind of mixed it is in your study.
The other thing Tor didn't have full time to talk about is the not missing at random. And I mean, that's a big topic area. So, you know, it wasn't really feasible for him to cover it in 15, 20 minutes. But I do think, you know, again, I like to try and put on the cranky reviewer hat. And I think the cranky reviewers are going to say, you assume missing at random, and I don't believe that because of the pandemic. And so there have been advances recently in relatively easy to use tools that allow you to do not missing at random sensitivity analyses. And I think we're all going to have to gear up and learn how to use those and write them up in a sensible way. Often sensitivity analyses come across as just sort of hand waving, but they're a little more principled, you know, things like if we were to add this much delta on for all the people that were not, that we think is not missing at random, how much would that affect the results? So we may have to gear up and think about doing those to address cranky reviewers' complaints.
One thing that occurs to me also is this is, you know, a lot of these different issues are going to come up in the actual COVID studies. People are following people and the pandemic is constantly changing. And the experience of the pandemic is changing. And so I'm sort of curious if any of you are working on studies right now that are COVID studies that are dealing with this issue of pandemic at one time is not the same as the pandemic at the next.
And a related issue is if you have a multi-site study, the pandemic in, you know, Arkansas is not the same as the pandemic in San Francisco.
And the trajectories are not the same. So you've seen there have been spikes in different parts of the country. It's not only now that we're getting spikes everywhere, now it's more uniform, yet the response of, you got 50 different states having 50 different responses in terms of restrictions, et cetera, to the same spikes. So the contexts are not only different geographically in terms of what the disease is doing, but also in terms of the response and the restrictions on behavior. So it can get very complex really rapidly if you're doing a multi-site study.
Thanks. I see there's just 2 minutes. I will just jump in and say that I think we're seeing remote data collection go in two ways in terms of qualitative data collection. It is either easier to get a hold of people, and I don't know if it's because of boredom or if people just have more availability and bandwidth to participate, or they are not showing up for focus groups. So it's making it really difficult to plan in advance. So I've seen it go both ways. And I would just say in general, listening to this discussion, I really feel for my colleagues. I don't do quantitative research, but I think that qualitative research is flexible enough to accommodate for so many of the problems you all are trying to grapple with.
For us today, especially given how busy everyone is. This is obviously a topic of a lot of interest given the attendance. So thank you so much for joining. Rochelle will have the slides. Maybe Tor's recording might have worked because we had a little bit of a Zoom technical difficulty today, but I really just want to thank everyone. Thank the implementation science group at Epi and Biostatistics, and also the CFAR implementation science working group for helping us sponsoring these events, and inviting you to the fourth part of the series, which is going to be on Tuesday, 8th, study designs for evaluating the impact of COVID-19 related interventions and interruptions. So with that, I will close this out, and thanks everyone.